والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the second section in chapter 4, uh, and it's about rules of probability. The first rule, we already mentioned it, we know it, but it's very crucial, so we have to mention this rule again. The rule that probability of any event, probability of any event is always a number between 0 and 1. So the probability cannot be negative, it cannot be greater than 1. That's the first rule. All possible outcomes associated with an experiment from the sample space. Uh, all possible outcomes associated with an experiment form the sample space. So this is the definition of the sample space, set of all possible outcomes. Therefore, the sum of the probabilities of all possible outcomes is 1. And this is the second rule. So for example, tossing a coin, we have head and tail. So the probability of head plus the probability of tail should be equal to 1. 1 is the largest probability. And we understand here that the probability of the sample space, which is S, is 1, because the sample space has all possible outcomes. But the probability of the sample space is always 1. And if you find the sum of the probabilities, sum of the probabilities of all possible outcomes, the answer should be 1. So what is EI? The ith outcome. Outcome number 1, second outcome, third outcome. You add the probabilities of all outcomes, it should be 1. So first rule between 0 and 1, the probability. Second rule, the sum of all probabilities of all outcomes is 1. The third rule, addition rule for individual outcomes. So if we define an event EI, and this event has 3 outcomes inside it, inside EI, how to find the probability of EI? We find the probability of EI simply by adding probability of E1 plus probability of outcome 2 plus probability of outcome 3. So the probability of an event EI would be equal to the sum of the probabilities of the individual outcomes that form EI. Let us take some examples. A study was conducted in a school on how students travel to school. Following are the data collected for 3 methods students use to travel to school: carpool, drive, public transport. Drive by himself, yani, student. These are the number of students who use each method of these methods. The question: construct a relative frequency table for the provided data. Okay, you can think of this table as category and frequency, and he needs the relative frequency table. So if you remember, we find the relative frequency by dividing each number, each frequency by the total. Did he mention in the question how many students? No. So we add them. We add 35 plus 14 plus 47, we get 96. So this is the total number of students. And then we divide 35 by 96 to get the frequency of the first uh, method. So it is, let us say, 0.365. After 4, we have 5, so I will write it 5. 14 over 96. This is the relative frequency of the second one, 0.146. And 47 over 96, the answer is 0.49. uh, the total should be 1. If the total is not 1, then try to, the total is 1.001. So the first one was 4 5. I will write it 4. So here the sum is 1. Okay, this is answering part A. This is the answer of part A. Part B, what is the probability that a student is not driving to school? Here we have an experiment. Okay, this is an experiment, and these are the results of the experiment. So to find the probability, we will use the relative frequency method. So the question, what is the probability that student is not driving to school? Well, not driving means he's using carpool or public transport. These two. So not driving would be 0.364 plus 0.49. This would be the probability that the student is not driving to the school. 0.854. Another part, what is the probability that a student either carpools, either or, either carpools or drives? Okay, carpools, what is the probability of he using carpool? 0.364 plus or drives to school 0.146. And let me ask you a question here. Are these methods mutually exclusive? Are these methods mutually exclusive or not? And the answer is yes, they are mutually exclusive because there is no intersection. There is no probability that there is no student who is using both. He cannot drive and go through public transportation to the school. Either he is driving or going to public transportation. Uh, of course, we are not discussing here an emergency case or something. This is in general. Either he is driving or taking public transportation or using carpools. These two are mutually exclusive, and the probability is 0.51. Another question. A sales manager has placed 3 products on display in a store. The following shows the probabilities associated with the number of these products that sell in the first 30 minutes on display. So this is the number sold. So 0 sold, probability that 0 items will be sold on the first 30 in the first 30 minutes would be zero point 0.2 immediately after in the first 30 minutes 0 sold, nothing will be sold. Zero point 0.2, 1 will be sold. Zero point 0.3, 2, 0.4. And how did he find these probabilities? Of course, this is his data. Okay, this he studied what happened to him in the last month or the last year, and he came to this conclusion, to these probabilities. Of course, if you add all the probabilities, the answer would be 1. And it is also here. If you add all these probabilities, the answer should be 1. And each probability, as usual, should be between 0 and 1. So you will not find any probability here greater than 1 or less than 0. The question here, what is the probability that 2 or more products, 2 or more, 2 or 3 will sell? So the probability that 2 is zero point 0.4. The probability that 3 will be sold is zero point 0.1. So the answer is 0.5. Again, if I ask you, are these here events mutually exclusive? And the answer would be yes, because either he will sell 0 or 1 or 2 or 3. Okay, these are mutually exclusive events. That's why when we find the union, or is the union, we just add them. Point 0.4 plus point 0.1 is point 0.5. Roll a six-sided die. What is the probability that the value? Of course, all of these examples are examples about rule 3, because rule 3, we add the probabilities of the events inside of the outcomes inside the events. And that's what we are doing. We are adding the probabilities of outcomes because he is asking about an event. This is an event that consists of two or more outcomes. So you just add the probability of the outcomes. All of these are exercises about rule 3. If you roll a six-sided die, the sample space is a number from 1 to 6. The question, what is the probability that the value will be an odd number? So he is asking about this event that I have an odd number. Now, the probability of each number of these numbers is 1 over 6 because the experiment is equally likely. So the probability of E would be probability of 1, which is 1 over 6, plus probability of 3, which is 1 over 6, plus probability of 5, which is 1 over 6, and the answer is 3 over 6. Or you can simply divide the number of items or outcomes in E over the total number because the experiment is equally likely. I will leave this exercise for you to solve. It's similar to the previous ones and again about rule 3. Let us study a new idea, complement rule. What is the meaning of complement? The complement of event E is represented by E bar. Okay, so when we write E bar, we mean the complement. What is the complement? The complement of an event E is the collection of all possible outcomes not contained in E. So anything which is not in E would be in E complement. So E union E complement will give you all the sample space because the element either in E or in E complement. Any element, any outcome in the sample space, either it is in E or in E complement. And now I have a question. Are E and E complement mutually exclusive? And the answer is yes. E intersection E complement is phi. That's from the definition. E complement, what are the elements in E complement? The elements in E complement are the outcomes not in E. So you will never find an outcome which is in both E and E complement. It has to be either in E or in E complement. So nothing in between. So there is no element inside both of E and E complement. That's why their intersection is phi. So E and E complement are mutually exclusive and their union would give you all the sample space. So we mentioned before that the probability of SS is 1. So from here, probability of E plus probability of E complement because their union as SS would be 1. So if you want to find the probability of E complement, it would be 1 minus probability of E. So that's the complement rule. To find probability of E complement, 1 minus probability of E. In fact, uh, we could have used this here or in any of these exercises. For example, here he asked about not driving. Not driving. So we can find the probability of not driving by 1 minus probability of driving. And what is the probability of driving? 0.146. So 1 minus 146 would give you also the same answer, which is 0.854. Okay, or this is using complement rule. Complement rule. So sometimes you can use many rules to get the same answer. Some other exercises. An inspector checks seven products from 0 to 7 to see if they are defective. So any of the products is defective. The possible number of defects and their probabilities are given. So the probability that two products are defective are defects is a 0.23 and so on. Okay, we have this table. If you add all of these probabilities, you should get 1. Now, what is the probability of one or more defects? One or more. What does it mean, one or more? It means 1, 2, 3, up to 7. So you have two choices to find this probability. Either you add all of these probabilities or you use the complement rule. So the probability of x greater than or equal to 1 would be 1 minus probability of 0. And if you take 1 and above, 1 or more, only 0 left. So the probability would be 1 minus probability of 0, which is 1 minus 0.03, which is 0.97. So if you add all of these probabilities, you should get 0.97, or the one who knows the complement rule can get to the answer quickly like this. Another example, the managing partner for capital consulting is working on a proposal for a consulting project with a client in Sydney, Australia. The manager lists four possible net profits. These are four possible net profits, okay, from the consulting engagement, and his subjectively assessed probability related to each profit level. We did not really talk about subjective probability, okay, but here an example about it. Subjective would be the manager will according to his experience will give these probabilities. Okay, he knows from his work and his experience in his work that the probabilities of these net portfolios could be like this. For such uh, kind of probability is called subjective probability. If you add all the probabilities, you should get 1. Now, the manager plans to submit the proposal if the consulting engagement will have a positive profit. Positive profit. So positive profit means this. 0 is not positive. So he is interested in knowing the probability of an outcome greater than 0. So what is the probability that outcome is greater than 0? So either you add these 3 or you use the complement rule. So he used here the complement rule. He called E the event with 0 net profit. So the probability of E is 0.7 as you see. And then probability of profit greater than 0 would be 1 minus the probability of profit equals to 0, and it would be 0.3. Let me talk also about probability rule number 4, addition rule, but for any two events, E1 and E2. We mentioned addition rule before, but it wasn't for two events. It was for how to find the probability of events for individual outcomes. Okay, this is for individual outcomes, while here this is addition rule for any two events, E1 and E2. When we need to find or the probability of E1 or E2, and when there is an intersection between E1 and E2. So if I ask you, are E1 and E2 here mutually exclusive? You must say, no, they are not mutually exclusive because there is an intersection between them. If there is an intersection, the probability of the union, of course, E or E1 or E2 also means the union. So this is probability of E1 union E2. So the probability of the union would be, how to find the probability of the union? You find the probability of E1, all of it, plus probability of E2, all of it. But then this region, which is the intersection, you have taken it twice, once with E1 and once with E2. So you subtract one intersection. Now you get the probability of the union. The union means everything. All of this region would be the union. So this is the addition rule for any two events. Let me solve this exercise. Drawing cards from a deck of 52 cards. We mentioned this experiment before. Now the question, what is the probability of drawing a red card or a king? Okay, let me call a red card event R, king event K. And the question would be, what is the probability of R union K? Or you write it or K, R or K. Okay. According to the definition, it is the probability of R, red, plus the probability of K, king, minus the probability of R intersection king. Now, what is the probability of red cards? How to find the probability of red cards? We have 52 cards in the deck. Okay. 26 of these 52 are red. Okay, cards. And 26 are black. So the number of red cards, to find probability of red cards, the number of red cards, which is 26, over the total number of cards, which is 52. What about probability of king? We mentioned before that there are 4 kings. How many kings in the deck? We have 4 kings. To find the probability of drawing a king, you divide the number of kings over the total number of cards minus probability of red intersection king. There are 2 kings red and 2 kings black, 2 black kings and 2 red kings. So there are 2 red kings. So to find the probability of the intersection, we divide the number of red kings over the total number. So you can add 26 plus 4 minus 2 over 52, and the answer would be 28 over 52. Or you can simplify this answer and give it as a decimal, or just write it 7 over 13. That's the exact answer. I will stop here, and inshallah next time we continue our discussion in section 4.2. If you have any